We're going to start talking about balancing chemical equations. In the previous video, we talked about writing word equations, then skeleton equations. Well, now we're coming to our final step here. So, to complete the process of writing a correct equation, the law of conservation of mass must be taken into account. The relative amounts of reactants and products represented in the equation must be adjusted so that the numbers and types of atoms are the same on both sides of the equation. So this process is called balancing an equation and is carried out by inserting coefficients. So our example here, we have CH4 plus O2, which produces carbon dioxide gas and gaseous water. So whatever is on the left of the arrow must be on the right. And if we have polyatomic ions on the same sides of the arrow, both sides of the arrow, we're going to group them as one atom. So we'll start to balance this. So since I see there's no polyatomic ions on both sides of the arrow, I'm going to go one atom at a time. Well, this is balanced. We have it balanced already. We have our 2 coefficient here for water. So what we're going to do here, we're going to write word and formula equations for the chemical reaction that occurs when, here we go. When doing these, just write everything down as they come on the screen. So in solid, sodium oxide, so Na2O, solid, is added to water at room temperature and forms sodium hydroxide, NaOH. And since it's dissolved in water, that means it's AQ. It's aqueous. So include symbols for physical states in the formula equation, which we have done already. Then balance the formula equation to give a balanced chemical equation. So let's do that. So remember, whatever's on the left side of the arrow needs to be on the right. So I notice a polyatomic ion is not on the left side of the arrow or the right. And when I say that, they have to be the same polyatomic ion. So I look on the, I'll draw a line here. I see I have 2 sodiums on the left side of the arrow and only 1 on the right. So how am I going to make or satisfy the law of conservation of mass? I'm going to need to put a 2 coefficient in front of this NaOH to have 2 sodiums now. But now I look, so I have 2 sodiums, I have 2 oxygens, and I also have 2 hydrogens. On this side of the arrow now, I have 2 hydrogens, and 1 oxygen here plus 1 oxygen here gives me 2 oxygens. So my equation is balanced. So if I look at this and if I want to read my coefficients, and remember, if there's nothing there, it's understood as 1. Okay. So my coefficients for this chemical equation would be 1, 1, 2. Our next one. It says the reaction of zinc and aqueous hydrochloric acid produces ZnCl2, so it's solution, so it's going to be aqueous, and hydrogen gas. All right, so let's balance this chemical equation. So there's not a polyatomic ion on each side of the arrow, the same polyatomic ion, so we can't use that. So we look. We have zinc, 1 zinc on the left side and 1 zinc on the right, so there's nothing to balance there. But if I look at the hydrogens and the chlorines, here's my issue. On my product side, I have 2 hydrogens and 2 chlorines. On my reactant sides, I only have 1 of each. So what do I need to put as a coefficient to make my reactant hydrogens and chlorines equal my product hydrogens and chlorines? Put it 2 here. And that's all I need to do. So my coefficient should read for this equation 1, 2, 1, 1. Now, you don't have to keep putting that 1. I just want to show you that our coefficients to start will be the number 1. Okay, so solid aluminum carbide. So Al4C3 reacts with water to produce methane gas and solid aluminum hydroxide. Okay, so we don't have any polyatomic ions here. So what we're going to have to do is we're going to have to start with one element and plug some coefficients in and check our work. So let's look here. So we have 4 aluminums on the left side here. We have 1 here, so we're going to need to put a 4 here. Okay, so now our aluminums match up. Carbons, we have 3 on the left, so we need 3 on the right. And now let's see where we're at here. So I have 4 aluminums on the left side, 3 carbons, 2 hydrogens, and 1 oxygen. On the right side of the arrow, I have 3 carbons, 12 hydrogens, 4 aluminums. So I have 3 oxygen, 3 times 4 is 12 oxygens, and 20, no, not 20, let's see. Let's erase this. So 3 times 1 is 3, so we have 12 more hydrogens. So together, I have 24 hydrogens. So I have 3 carbons, 24 hydrogens, 4 aluminums, and 12 oxygens. So when I look at this, what am I going to need to put for this water here to make sure my hydrogens and oxygens equal each other? And I think it's going to be a coefficient of 12. So if I do that, I would then have 24 hydrogens and 12 oxygens, which would make each element equal on both sides of the arrow. So my coefficients would read 1, 12, 3, 4. Now, if you have coefficients in there, they can be divided by, or we could reduce in the lowest terms, we could do that. But in this case, we cannot, because aluminum carbide has a coefficient of 1. And then our last example here, okay, so now I see I have some polyatomic ions. So I have a sulfate on the left side and a sulfate on the right side. So they both have 1 sulfate apiece, so we don't have to balance that. Sodiums, we look here. We'll start with our sodium. We have 1 sodium on the left, and we have 2 sodiums on the right. So what do I need to put as a coefficient here to make this equal to 2? Put a coefficient of 2. So now I have 2 Na and I have 2 Cl. On the product side, I only have 1 Cl, so I need to put a coefficient of 2 to make that equal to 2 Cl. But that also makes 2 hydrogens, which now equal my hydrogens on the left side. And we have our 1SO4 on both sides. And now our equation is done. So our coefficients will be 2, 1, 1, 2.